Hello and welcome to today's VMware Webcast. Before we get started, there are a couple of housekeeping items that I would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located to the left of the slides window. You can also use the question and answer box to get technical assistance if you should need it. The tabs located in the question and answer box are where you can find additional information about today's presentation. Today's presentation features streaming audio only, so there is no need to dial into a teleconference. You'll need to make sure that your computer speakers are turned up in order to hear the presenter and today's content. You can also fine-tune the audio by using the volume controls inside the media window. This presentation console allows you to interact and customize the layout to fit your viewing needs. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner of each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of your screen. Now I'd like to turn things over to today's presenter to get things started.
Hi, my name's Steve Tegler. I'm a Senior Director of Systems Engineering here at VMware. And I've also got Sachin Thate, who's a staff SE on the team that's going to join us as well. We're going to talk today about deploying and managing what we call enterprise-grade Kubernetes. And so the agenda we have today, we're going to go through a quick intro where we're going to talk about software development challenges and really talk about the possible cures that exist around those software development challenges. I'll do a container technology level set because sometimes when we talk to vSphere administrators, they've heard of containers, they kind of understand it, but I want to do a quick level sets to make sure that everyone has a base level of knowledge. Then we'll go into the details of Kubernetes itself with PKS, and that's going to take about 30 minutes. And we've really weighted this to a 20-minute demo. So it's about 19 or 20 minutes to go through and actually show you some pieces of PKS. And then we'll end with kind of your path forward, like, all right, sounds great. What do I do next? In addition, one thing I wanted to note here, up at the top, you see this banner, it says additional YouTubes available. So on any one of these slides where you'd like to understand the technology a little bit better, there's going to be a YouTube link to typically a light board or a demo, which can go into the details on the individual solution on that particular slide. We're also going to try and post that in the chat as well, and these slides will be available. So let's jump right in. So everyone's goal here is to optimize software development for their company. We all know what kind of advantage software gives us in our companies, but let's dig into the details. When we look at the software development process around, putting something in test, moving it to staging or pre-production, moving it to production, typically we have to create code to do that. We have to create code to manage the actual app development. The problem that exists is that there's a lot of infrastructure snowflakes that makes this process fragile. And when the process is fragile, it's obviously very difficult for the business to react quickly and do things in a consistent and repeatable way. Now, specifically, why are things fragile? Well, in a lot of cases, these software pipelines deploy to like a hard-fixed static IP address of a virtual machine somewhere. And as a result, there's long-lived operating systems. We know what happens to long-lived things. They have configuration creep over time. There could be infrastructure variability, which again poses a problem because it's not consistent. And even something as specific as firewall policy. In test, maybe I don't have firewalls, but maybe when I move to staging or other test scenarios, I do have firewalls, and that could potentially break the app, so to speak. So the solution here is around consistency and repeatability. The question is, how do you do this? And there's multiple ways to do this. Infrastructure as code to maintain the infrastructure consistency, configuration management for various tasks, containers and container platforms, which is what we're going to talk today, and then platform as a service to abstract even more and provide more consistency. Fundamental challenge in front of us, we need to apply software methodologies applied to these IT services that we're creating. And again, it's the how part of this is frequently debated. Everyone's got an opinion of how to solve this problem. And the reality is, I don't personally believe there's a silver bullet. It's more a reality of how much of each. So let's jump into a container discussion, specifically a quick level set. A lot of times there's a quick discussion around, geez, what about virtual machines or containers and containers, and then Docker and Kubernetes. And before we jump into this, I wanted to do a quick poll here to ask where, everyone on this webcast, where you are with your knowledge of containers. And you can see here from the poll, we've got just starting my learning journey. You're playing with them today, or you're currently using them at your company. So I'm going to take about 20 seconds here to let you fill this out. Great. That looks like most of the responses. So let's move on to the results here for everyone. Actually, I'll give it a couple more minutes. Looks like a few more responses filtering in. Great. Let's move on. Let's take a look. So, most of you, it looks like you're just starting your journey or you're playing with them. That's, boy, that's about 80% of the folks. And then we've got currently using them as 20%. And that's pretty typical. Especially for what I would consider a vSphere audience, so to speak, where you may or may not be using containers in your current role. But that's great to know. Thank you. So, as a result, I kind of want to talk about basically containers are doing to operating systems what virtual machines did to server hardware. This is kind of the comparison I like to use. But there's one caveat here. There seems to be a much quicker adoption cycle with containers and how they're being used today. And so I want to talk specifically around the comparison of virtual machines and containers, just so you kind of understand. So if we look at the application stack, so to speak, on the left-hand side here, we've got the physical infrastructure, we've got the operating system and the application dependencies, and then the application itself. We know where server virtualization sits. It sits here. It sits between the operating system and the physical infrastructure. So if you're in the operating system looking down, you have a very finite number of pieces of hardware that are presented to you. So you get to really streamline your operating system. You get to right size the virtual hardware that operating system sits in. It's mobile, so on and so forth. These are all things that VMware has been doing for 20 years now. Now, the one thing I want to zero in on is this piece here. And so normally what happens is you'll right-click, deploy a gold image from template, and then someone will be responsible for prepping the operating system or installing all of these dependencies that are required before you actually install the application. Okay? And right now, this is kind of a hard day two problem. Anyone can write a script to configure an operating system, but it's maintaining that over time. And the classic example here to do this, and you can do this today, it just requires a lot of work. It's with configuration management. That's typically how this is solved. And the issue becomes like, what happens if my golden operating system image, what if that changes? That means I need to actually go through and make sure all my configuration management still works because I have a different starting point. I have a different operating system starting point. So it's not that it can't be done, it's just a lot of work. So enter containers. And so here's our same application stack. And the big thing here is that you've got the operating system and the application dependencies. What we're going to do in a container world, the container world is really about an operating system abstraction. So instead of custom configuring every operating system to load an app, I'm going to bundle all those dependencies with the application. And I'm going to call that thing a quote unquote container because it contains not only the application, but also the application dependencies. And building this container and maintaining this container is much easier than configuration management. Certainly, there's a lot of details on that, which we can follow up on. But the other thing is the underlying operating system becomes very ubiquitous. You don't need to do a lot of customization. You just need to provide an operating system that knows how to run containers. The other thing to note here is this relationship. So we've got the container host OS. Certainly, I could install that right on bare metal, right on physical infrastructure, but I still have those same problems that I had before virtualization, where I have to basically bloat that container host operating system and make sure it works on any given physical hardware. I'm constrained by the physical hardware. I have to coordinate the networking and the security and so forth. And that's a little bit more difficult to do in the physical world, just fundamentally because of the variability. So there's still a great need for virtualization in the container space, and nearly everyone I talk to on their journey is starting off certainly in a virtualized world. So again, up here, there's the banner for if you want more details, you want this explained again, there's a Lightboard video on that subject. Docker and Kubernetes. So Docker, this is about containers one at a time. This is about running a single container. That's the core Docker engine, the Docker functionality here. And if you look at the actual business app, typically it's made up of multiple containers. So you've got a web front end, you've got a load balancer, maybe there's a database on the backside that you've actually running as a container. The point is, it's not about an individual container per se, it's more about orchestrating multiple containers. And when it comes time to upgrade this app, how do I do that orchestration? Do I start issuing command lines on individual containers? No. The answer is something called a container orchestrator. And that's exactly where Kubernetes comes into play. I've got my Kubernetes cluster that I have an API with and I deploy and talk to. And what I'll do is I'll create a series of YAML files, a series of text files that specify not only the containers to run, but a lot of the parameters around load balancing and storage and so forth. And I can package this up, I pass it to Kubernetes, and it will just take care of running that entire business app for me. So scheduling, provisioning, and resource management of multiple containers, that's what Kubernetes is all about. The scheduling wars, so to speak, are over. Kubernetes has become the de facto standard. Major container solutions, the major container solutions that had different technologies in Kubernetes, they've all announced Kubernetes support. All the major public cloud providers have a Kubernetes-based container service. Okay, so that's the basics on the containers as a level set. Now I want to get into the details around VMware technology. So before we do that, I do want to ask a poll to find out, from the people on this phone, go ahead and pick the types of area expertise that you have. So we've got infrastructure, we've got platform. So platform could be beyond infrastructure. This could be another abstraction level to the actual application or feature developer. And then, of course, application, are you an actual feature developer or whatnot? And then we've got a combination of both. So go ahead and I'll give you about 20 seconds here to respond. Don't forget to hit that submit button as you choose your area of expertise. Okay, 5, 4, 3, 2, 1. All right, let's take a look. So a lot of folks from infrastructure here, over a third of the people on the phone. Platform, which would sit on top of the infrastructure team, creating other internal IT services. And then we've got application folks, not too many application folks on the call, infrastructure and platforms. So yeah, certainly from the virtual infrastructure up to, through the platform, providing additional IT services right on top of infrastructure. Looks like you're the majority of the folks. Thanks for letting me know. So when we talk about the different services in IT, we're really talking about the abstractions we want to hand to, I say developer here, but this is really the end consumer of the service. So for IaaS, we're very familiar with that. This is about a very simple abstraction layer, like create a VM, connect it to a network. And it's a very simplified API versus, say, going directly to the virtualization technology APIs individually. Typically, this is used for automating traditional applications. So you don't want to change the application at all. You just want to change how the application is deployed. And that's where IaaS comes into play. We have two products there, VMware Integrated OpenStack, vRealize Automation today. The next step up from an abstraction level here would be the Docker API. And so this is about providing that container runtime. So if I'm in IT, the service I'm providing is the access to the Docker API and the freedom to use the Docker API however I want. For the consumer, that means they're going to have to take their application and they're going to have to build a container. They're going to have to build all the dependencies for that container. And then they're going to need to issue that quote unquote Docker run command. Okay. So you can see there's quite a bit of work they need to do, and the main piece being the container orchestration piece. VMware does have a technology here that you've probably heard of, vSphere integrated containers, that can help out in this world. Certainly, if you just need a Docker API, an interesting use case here is maybe a robo example where I just maybe need to run 1 or 2 containers in a remote office or whatnot. vSphere integrated containers might be a fantastic fit for that. And I believe we've got some documentation on our website around that solution. If not, feel free to reach out to your individual VMware account teams. Now let's talk about kind of the real focus of this presentation, which is about Kubernetes. So what's the burden, or what does the consumer need to take on? Well, here, if they're given a Kubernetes API, if that's their consumption, the application, basically you need to build the container, then you need to architect the dependencies for that container and the actual IT or business application. And Kubernetes gives you some great constructs to do that. I'll spend a little bit of time on that. But basically, the containers, how everything's all put together, you pass that to Kubernetes API, and the person that runs this container service, right? And specifically, we're going to talk about PKS. They're responsible for the relationship between PKS and the underlying infrastructure. I'll spend some time on that later. And then if we take a look at the ultimate abstraction, which is the Pivotal Application Service or Cloud Foundry API, in this case, we're basically taking the application and we're passing the artifact, the actual software artifact, to the platform, and the platform will automatically take care of building the containers. The platform will automatically know all the dependencies and whatnot. So that's Pivotal Application Service. That's the ultimate abstraction for the consumer, depending on what they want to do. Bottom line is, on the right-hand side, for the consumer, there's a lot less complexity, right? On the right-hand side, you don't even have to worry about building a container. But on the left-hand side, we got ultimate control. And then we've got some things in between. So, I'm not here to mandate that we should focus on any given one of these. There's probably, again, there's never one right answer. There's probably a multitude of answers depending on where you are on your application journey, so to speak. So let's zero in on PKS. And the first thing I want to do is talk about PKS and Kubernetes, because they aren't necessarily the exact same thing. And what I mean by that is that with Kubernetes, what is Kubernetes responsible for? It's responsible for container scheduling, or think of it as the overall application and maintaining that application. The scale of the application, the resiliency of the application, and the day 2 of the application. How do I update the app? It gives you, that's what Kubernetes is good at. It's all about the app. It is the desired state of the application. But what about PKS? What is PKS? Well, PKS is about the actual Kubernetes cluster creation, the scale of Kubernetes, resiliency of Kubernetes, the day 2 of Kubernetes, like patching and upgrading Kubernetes. Think of PKS as the desired state of Kubernetes clusters. And it is not a one-to-one PKS to a single Kubernetes cluster. You can actually deploy multiple Kubernetes clusters, as I'm going to show you in a future slide. So right now, it's a joint engineering effort between Pivotal, VMware, and Google. We are a certified version of Kubernetes, so we pass the. They have a series of tests where you can, basically maintain that you reach a minimum, features and functionality and API, so to speak. But in effect, CNCF certified Kubernetes. The big thing here is we're shooting for constant compatibility with GKE. So it's not just about having a certified CNCF version. It's about maintaining the features and functionality of a major cloud provider, and arguably a major cloud provider that's backing Kubernetes. Okay. So Kubernetes is not all roses. There's always challenges with new technology, and this graph shows the CNCF. They did a user survey back in December of 2017, and you can see the majority of the issues are related to infrastructure type things like security, potentially, storage, monitoring, networking, the overall complexity. And these are exactly things that are addressed by PKS. We zeroed in, VMware and Pivotal. VMware is obviously very strong in the infrastructure space. We've done things in infrastructure before. Kubernetes is just a different way to consume infrastructure. So there's a lot of lessons learned that we can apply to Kubernetes space. And so specifically, let's talk about mapping Kubernetes to your infrastructure. And let's just use the example here that I need to architect a specific application, right? And so I'm showing here that this app dev wants to deploy an elk stack. And they're going to do this, he or she is going to do this, and they're going to architect the elk stack on top of Kubernetes. And so what they do is they look down at Kubernetes and they leverage the abstractions in Kubernetes, you know, things like availability zones, security policy, load balancer, persistent volumes, right? Getting application metrics. They want that out of their Kubernetes cluster. Okay. Kubernetes gives you a way to define all these things, but it does not give you the technology to actually implement the thing. And what I mean by that is that if we look, we're going to have to take each one of these and we're going to have to map them down to an actual infrastructure technology. A great example here is persistent volumes. Eventually the data needs to end up on a disk. How do I map how I define a persistent volume in Kubernetes down to an actual storage solution technology under the covers? And that is exactly what this individual here, this operations person, and you can think of him as like a Kubernetes architect or operator. Another word we're using is a platform reliability engineer. So if Kubernetes is the platform, their sole job here is to not understand an elk stack, but understand what the elk stack needs. Offering these Kubernetes primitives like mapping an availability zone down to a specific rack in a data center somewhere. A security policy, you're going to need to implement that on some sort of security technology. Load balancer, same thing. That needs to map down to a different technology. So their whole job is mapping these Kubernetes constructs down to infrastructure. Now, arguably, we'd like to think that a lot of our vSphere administrators are going to be the individuals that do this. And so they're going to want to know, how do I map an availability zone down to vSphere, security policy, the NSX, distributed firewall, load balancer, NSX, data, persistent volumes to data source, and so forth. The metrics, like that Wavefront, is a great technology. So they're going to know, like, availability zones are mapped to vSphere clusters, right? So there's all these mappings that occur down to the technology. And what PKS does is it gives you a really easy way to perform these mappings. It's a consistent and repeatable way to map Kubernetes constructs to potentially your existing infrastructure or even to public clouds. And so the thing is even if you did learn what an elk stack was and you didn't know, eventually that app dev is going to go deploy and do something different, whether it's Spark or some other app. And the idea is focus on maintaining the Kubernetes constructs and those abstractions and delivering the right abstractions and delivering them safely, consistently, and repeatedly. Okay, so let's specifically, I don't like to just talk about a claim about fixing the actual top challenges of Kubernetes. I want to actually show you or demonstrate to you how it's done. And so the complexity and scale discussion, that's handled with a technology called BOSH. Networking and security is NSX. Storage is something called Project Hatchway from VMware, and that's about using traditional data stores in the container world. And then monitoring and logging with vRealize and Wavefront. So the first one, the way to illustrate BOSH here is really about talking about PKS, how it actually works. Like, how do I actually get a Kubernetes cluster? How is this thing built? So at the heart of this whole thing is a technology called BOSH. Think of BOSH's core functionality as deploying and managing virtual machines and maintaining their state. So I deploy a VM and I want to make sure it's configured that way at any point in time, however I requested it be deployed. So that BOSH gives you the constructs to do this. It's been around since about 2010. It was invented it was conceived at VMware. It's open source. It ended up going away with Pivotal. When Pivotal separated from VMware, they maintained and really been establishing BOSH as a great tool to use to deploy and manage virtual machines in public clouds. And so the key point here is that BOSH has this thing called a CPI, or a cloud provider interface. Think of the CPI as a translator to any major IaaS. So what that means is if you architect your application in BOSH, the CPI will take care of the heavy lifting of deploying it to various different public clouds. So in our case, Pivotal and VMware, we've got, and Google, in fact, we've architected Kubernetes with in BOSH constructs. So we call that a BOSH release. So we basically architect Kubernetes one way, but that's going to give us the luxury of deploying to any given cloud environment. This culmination of these things that we're working on is something called CFCR, which is an open source project. So CFCR is open source. I see the main engine here that's running. What does PKS give you on top of that? What PKS gives you is the main thing it gives you is something called a PKS control plane here, which I'll spend a little bit of time what that does in a second. But PKS also includes the bundling of Harbor, which is a private container registry. So if you don't have a container registry, you can do that. Also service brokers, and certainly the CNI configuration for something like NSX. So what the control plane does here is that it configures the day one meaning it's going to deploy CFCR, configure it. It's going to configure this CPI with vSphere. You're going to just give it basic credentials for an NSX deployment, and it's going to go out and automatically configure all of this stuff. The idea is I'm going to give it a simple parameters, and it will go out and configure all this stuff for you. So to remove that complexity of, think of it as all the glue that needs to exist between all this. Now, day one is one thing, but the really hard part is day two. How do I actually patch and upgrade this thing? What happens to failures of the Kubernetes cluster? How do I scale a Kubernetes cluster? Well, that's where this thing really shines. PKS really shines. So here I'm going to show you an example. So once I've set this thing up, I can issue a very simple command line. It's called PKS create cluster. This example shows the name of the Kubernetes cluster and then how many nodes I'm going to want. And I basically pass that API or CLI call to the PKS control plane, and it will go out and it will actually deploy and configure a full Kubernetes cluster. It defines all the networking, all the storage requirements, everything that's required for that Kubernetes cluster. I can get a brand new cluster with a single command line. There's no customization required. Okay, so that's one thing. That's the day one aspects here. Day two aspects. So I talked about, manage the failure scenario of managing day two failures. What happens if a node fails? It's one thing to be notified that a node is down and then a human being has to go in and run a script or a configuration management playbook or something like that to recover it. But what we have here with PKS, and because of BOSH, we're monitoring each and everything here. So if a node dies, there's a BOSH agent on that. And if that agent responds, BOSH will go out, it will delete that node, and it will recreate it. These are immutable things, and they can all be recreated by BOSH. And most importantly, it happens automatically. You can also issue a resize, so scale, right? If I need to go out to a cluster and grow it by another couple nodes, that's a simple API call. That's not running a bunch of configuration management tools to get it. It's a simple API call to scale this thing out. So super simple way to manage your Kubernetes clusters. All right, next topic is networking and security, which is a hot topic around Kubernetes. And in a lot of cases, people look, because they hear NSX is included with PKS, it comes with it. They ask, well, can I just use Flannel? So we get into these conversations around, should it be NSX, should it be Flannel? Now, the thing that sometimes isn't, if you're really not dug into it, Flannel is only layer 2 connectivity between pods, or if you're not familiar with the pod concept, think of 2 containers in any given Kubernetes cluster. So it's the layer 2 connectivity there. Of course, NSX has this. It's got layer 2 connectivity. If you need layer 3, meaning I need to get out of the cluster, or I need to apply security, that's going to require another technology. In the open source space, it's called Calico. Okay, so that's going to give you the layer 3 and layer 4 connectivity. NSX has that included as a part of it. So the open source community, if you haven't heard, they have, they bundle talking about these 2 technologies, and they call that Canal. But as of today, I don't believe there's any sort of actual configuration connectivity or a simplified way to deploy them both with Canal. It's merely a term to describe the use of both. But we're not done here. Most cloud native applications need some sort of load balancing. So again, from an open source perspective, you can do Nginx or HA proxy. Those are 2 common methods to define load balancing, but it requires you to do that separately. NSX load balancing is available to you, included with NSX. And so you can see what we're doing here on the right-hand side. It requires the configuration and the monitoring and the management and the metrics collection from potentially 3 different technologies. And so you don't have this kind of, think of it as a single source of truth for my overall network connectivity. And this is, on the right-hand side, these are technologies only for Kubernetes networking, in most cases within only one Kubernetes cluster. So, but what NSX can give you is not only the networking inside a single cluster, the networking across multiple clusters, and the networking all the way out to virtual machines. So it truly does give you a way to go out and map from a Kubernetes pod all the way out to my virtual infrastructure. And so the challenge on the right is not necessarily a feature and function one. It's more about the end-to-end operations, the configuration, the troubleshooting. Do I have to get a bunch of new tools? The different locations, just the statistics, like if I want to see what's going on in the environment, adds overall complexity to the overall architecture. And so, of course, NSX does give you that end-to-end configuration and troubleshooting. Some of the existing operation tools you already have probably work here, a centralized way to look at things. And, without, Sachin is going to go through this in his demo here. There's specifically a tool called TraceFlow, which allows you to actually not only draw the logical connectivity between 2 devices, two pods, but also virtual machines. It shows you the firewalls and so forth they hit. I'm not going to spoil it. We'll watch the video and see that. Of course, NSX, also good to mention, it also has the traditional operation tools like port mirroring and whatnot, all that now extended into the container world and Kubernetes world. So that's it on NSX. Last topic here is persistent storage challenges with Kubernetes. And this is a great quote that our storage folks at VMware like to use. There's no such thing as a stateless architecture, it's just someone else's problem. And so what makes it hard, though? We have to define that first before you can understand what kind of value we're providing. And if we look at, if I were to do persistent storage today with kind of, call it DIY Kubernetes, I'm going to have to go out and I'm going to have to find a storage platform that has something called a cloud provider. If you're not familiar with what that is, think of it as like a plugin for Kubernetes for that storage platform to work. And so I need to go, first of all, I need to find a storage platform that has one of these cloud providers. The storage platform needs to support the features and functionality of Kubernetes. So namely like storage classes, stateful sets, those types of things have to be supported by that storage platform and the cloud provider it uses. So once I have that storage platform, then I need to go out and I'm probably going to use like configuration management. And I'm going to need to install the cloud provider and all the hooks in all these nodes. And so I'm going to have to use configuration management everywhere. Now, again, this is, you can write these, the code to do this. It's the maintaining over time that is really hard, okay? And so the maintenance of this, think of this platform. So not only Kubernetes, like if I had to update Kubernetes, how do I know if that's compatible with my cloud provider? If I have to upgrade the storage platform, how do I know how that affects Kubernetes? So really what happens is there becomes a high risk of snowflakes here in this environment where you're having to manage this stuff yourself. And so enter Kubernetes, our value proposition, not necessarily with PKS, I will explain exactly, but just in general, running vSphere as the technology underneath. First of all, data stores here, any data store in VMware is supported here. The data store is the abstraction we communicate with. And what that means is that any storage product on the HCL of vSphere can work here. So that's vSAN, VMFS, NFS, they all work. We have operational consistency. So if you're already using SPBM, where you've defined maybe SSD storage or thin provision or whatnot, right? All of that can continue to work here. So you get this operational consistency. And what happens here is that we take these storage policies and we can map them up into Kubernetes and make them available to the end consumer. So the end consumer can pick, I just want a regular storage class. I want an encrypted one, dedupe. I want it fast. Maybe that's the SSD. So they can choose this. And I mentioned this is all available just because you're using vSphere and you're using a technology called Project Hatchway. The thing PKS brings you and delivers you is the consistent and repeatable configuration and maintenance of Project Hatchway across all of your Kubernetes clusters. And there is huge value there from an overall operations perspective. So that's the short story on the storage value prop. Now, the final thing here is around operations and tooling. Now, rather than dig too deep into operations and tooling, a lot of times this is handled by live demo, and we actually have a PKS and Wavefront webinar happening on August 16th at 10 a.m., which should be a great event, and we're really going to dig into Wavefront as a technology here and how it integrates with PKS and Kubernetes in general. So it should be a great thing, and look for go ahead and register for that, and look for that on August 16th. So to end here, before I hop over to the demo, so just real quick, PKS and the whole VMware portfolio, you've got, of course, everything in this red box is PKS. So if you quote unquote purchase PKS, you get all this stuff. You get a Harbor container registry if you want to use that. You get entitlements to use NSX for Kubernetes workloads. You get BOSH, of course, you get that big control plane. That, of course, can all run on top of vSphere and vSAN in addition to public clouds. On the left-hand side, you see the vRealize suite. Wavefront, of course, at the top. That's a really big one we're focused on because of the types of workloads that get deployed, but also vRealize Ops, Log Insight. They're all providing some hooks into PKS and Kubernetes. So most comprehensive solution. So as you think about building Kubernetes, it's not just like Kubernetes, the technology. It's what do I need to get that Kubernetes cluster up and running and all the glue I need to provide. So from the physical infrastructure, virtual infrastructure, storage persistence, networking, so on and so forth, and then the monitoring and logging and analytics required across potentially all those new technologies. So the idea is we want to leverage what we have. Like, let's use everything we possibly had, but provide that same level of service. So we can use the software-defined data center on top of our existing physical infrastructure. When we start getting into the Kubernetes place, we've got the cloud storage provider. That's going to give us storage. Networking provided by NSX. BOSH is handling the life cycle of the actual platform itself. You, of course, got just vanilla upstream Kubernetes, and we got our Harbor container registry. That is what PKS provides you. It's going to put all this together for you in a consistent and repeatable way. And we've got the whole vRealize suite and potentially Wavefront there, which are supporting technologies for the management and the operations. All right, so now we're going to move into demo time. Show a little bit of a fib here. It's not Sachin Thate, it's virtual Sachin Thate. Recently, he had a conflict with attending at the time we had this scheduled for, so I had him record a demo, and I'd like to kick that off right now.
Thank you, Steve, and thank you all for joining us today. Now for the demo part of our program. Let's discuss the PKS architecture at high level, and then we'll initiate our actual Kubernetes cluster deployment and see how BOSH starts creating the cluster, and that's reflected in vCenter. And then we'll take a look at, while the cluster is being deployed, we'll take a look at the components that are being created automatically, such as the load balancers and the logical routers. And that we will do in the context of an application that is already deployed on a pre-deployed cluster. So let's begin. Let's take a look at the architecture. So it all starts with a virtual machine called Ops Manager. And Ops Manager is delivered as OVA, so you can install it just like you would install in any other OVA. And then with that, that's Ops Manager UI is where you would now install things like BOSH and PKS and Harbor. And the place where you deploy these are simply vSphere clusters. Here they are designated as availability zones, but they are just vSphere clusters. So management, as the name stands, you would deploy the management components in there, and that would be BOSH, PKS, and Harbor. And then AZ Compute is where you would deploy the actual Kubernetes clusters. So the worker nodes as well as the master nodes. So with that, let's initiate a cluster deployment. That way we can start the deployment and then we can come back and take a look at the application. So let me get back here and let me look at creating a deployment. So I'm going to create a small scale deployment here with just one node because I only have, this is just a demo environment and we have short time. So I would like, if possible at all, I would like to get this cluster deployed during the demo. So let's start the installation or deployment of the cluster. And let's take a look at vCenter. We should soon see some activity that's happening in vCenter as Bosch is working on deploying. And there we go. So Bosch is cloning the virtual machines. And now once it powers the machines on, it will start installing the software. So Kubernetes software as well as NSX inside, NSX for networking and security. And then it will start testing to make sure that node is up and running before it commissions it into production. So while it's doing that, let's take a look at application that we have deployed in other pre-deployed cluster. So this application is written by one of our colleagues, and rather than just having a hello world, this is a pretty good proper application that actually takes a live data from FAA for the aircraft registry that already exists in MySQL. And then upon called upon, it can tell you the position of a given plane. If it's in the air, it can give you the longitude and latitude of that plane. So let's take a look at the app architecture. It starts with the load balancer, which got created automatically when we deployed the cluster. And the way that load balancer looks, it's just once you go inside NSX and you go in load balancer, it deploys one load balancer per cluster. So now this is telling you that because we have only one load balancer, that means we must have only one cluster. And that is true, that we just have one cluster and second one is being deployed. So going back to the application architecture, so you have a load balancer that is load balancing across these front-end pods. And then the front-end web pods would talk to the API server. And then the API server would then talk to the MySQL to get the data. And it will also talk to Redis to get the position that's cached in real time. So that's quickly the overview of an architecture of this application. It also depends on persistent storage. So as you can see, this is a MySQL database. All these other pods are stateless, and it doesn't matter if they get killed, their storage goes away. And when they get rescheduled, they get brand new storage. It doesn't matter because they don't have any persistent data. But that's different for MySQL. MySQL has persistent data. So we cannot afford to lose that data if the pod dies and gets rescheduled. And hence we are using persistent storage. And that's given to us by the integration of PKS and VMware's Project Hatchway. That will look little bit more into detail little later on. So let's take a look at the other components. So if I go under the server pools, and I see it here that I have a server pool under the load balancer, and let's look at the pool members, and I have one pool member, 16.6. That means I must only have one pod for front end here rather than 3 pods. So let's see if that is the case by going to command line here. And if I do, let me clear the screen. So if I do get pods, and I have just aliased it so that you don't have to suffer through my bad typing. So if you look at it here, and sure enough, we just have one front-end pod right here, and that is 16.6. And if we go back here, you can take a look for the pool member, it is 16.6. So if I go to my application, Plane Spotter, and as you can see that when I go to the application, it's telling me which web server I'm going to, and it's going to 16.6. What if I click on some other tab? Well, it's still going to 16.6. Why is that? Because we only have one pod. So it doesn't have anything else to load balance against. Well, that's no fun. So let's go and fix that. Let's scale it out to add at least one more pod so we can see load balancing happening. So let's go to the command line and let's scale the pod out here. So I'm going to take this command, and the replicas currently is just 1. So I'll make sure we can scale it out to 2. And there is a recording bar in my way that I'm just going to move out. So here we go. So I'm going to say that give me at least 2 replicas. And I'm going to execute that. And once I do that, then if I look at my pods, you can right away see that a container is being created right now. So once the container is created, we'll have additional pod onto this front end part of the application. We only have one right now. Once we scale it out, we'll have two. So let's go take a look if it has created it already. And yes, it's up and running. So originally we only had 16.6. Now we also have 16.5. So let's say if automation, the built-in automation actually worked, because I haven't really done anything different. Now let's go take a look at it. And I have to do a refresh here, and refresh does take a little longer. So let's take a look at the server pools. So I'll go to server pools and I'll go to my front-end pool here. And let's take a look at the pool members. And I have to do a refresh, as I mentioned, and that takes about 17 or 18 seconds or so to get the refresh done. So in the meanwhile, let me show you which nodes these pods are scheduled on. So if I do kget nodes, so K just stands for kubectl, and -O for Y to get IP addresses. So as you can see, I have 3 nodes, and each of those nodes have this long UUID to designate them. And looks like I have pods scheduled across all of these nodes. So I don't have a node that doesn't have any pod scheduled on it. And MySQL pod is being scheduled on this node that starts with 23D and has an IP address of 2.8. So that's important for us to remember for the later part when we do persistent storage. In the meanwhile, let's turn our focus back to the front-end pods. We have 16.6 and 16.5. So we added one more pod. So if I go back, sure enough, NSX completed the refresh, and without any manual intervention or without having to ask the load balancing person to add it to a pod, it automatically got added. So now if I go to my application and go to, let's say, home tab here, sure enough, now I'm getting load balance. Now it's 16.5. If I go to my app health, it's 16.6. So now I'm being load balanced automatically. So now let's take a look at other tool that helps us troubleshoot. And this is built into NSX. You don't have to purchase it, or you don't have to write some software to do this. And the usefulness of this TraceFlow tool is if you're troubleshooting an application and you want to trace end to end, you don't have to worry about gathering people from firewall team and people from networking team and people from application team and a server team. You can simply go and trace from pod to pod by injecting the traffic that you want it to traverse. So in this example, and since we are short on time, we are going to do this relatively quickly. So if you go to Plain Spotter app here, and we are going to trace to MySQL. So let me go to MySQL. So MySQL pod, and I'm just going to do a simple trace here, but you could actually get pretty advanced and change it to TCP, and you can actually put a real payload data in it. But for now, we'll stick with default. And this takes about 14 to 15 seconds to complete the trace, but it's a very useful tool. Not only it will show you different logical components that it's going through, but it will also show you the firewall rules it is traversing. And in this case, it is traversing rule number 2. So for example, if somebody changed this rule or made a mistake earlier somewhere else and broke it, so the traffic was getting denied by mistake, this will actually show you that the traffic is being dropped, and it will tell you the rule number that it's dropping. So you can quickly go and rectify it. So that's a huge advantage of this tool, and it's very popular with our customers. So let's get back and look at our application and switch to persistence of our persistent part of our demo. So if we look at this application, and typically when you have a SQL pod and it has a persistent storage, because if it did not, and if the pod happens to die and gets rescheduled on some other node, you're going to lose the database if it's not persistent. But with PKS and Project Hatchway, which is integrated in PKS, now you can create persistent storage on ubiquitous data stores that you have available with VMware. So it doesn't matter underneath that data store, whether it's NFS, SAN, or if it's iSCSI, it doesn't matter, or it doesn't matter what vendor it is. As long as it's represented by data store, we can create persistent storage on top of that. So when the pod gets created, it asks for persistent storage. The right VMDK gets mapped to the right node. And if the pod dies and gets rescheduled on some other node, the VMDK gets automatically mapped to that new node, thus not losing data for MySQL pod. And let's see that in action. So let's get back to our screen here and take a look at MySQL. And MySQL is scheduled on this node that starts with 23D. So let's take a look at 23D. And that has, the node has an IP address for 23D. It has an IP address of 192.168.2.8. So let's go to our vCenter and take a look at that. So if I go to my nodes, 2.8, and this is the 2.8 node, and I look at the configuration for this node. So let's go to edit settings, and let's take a look at this node here for the hardware that it has. What I want to show you is that it has mapped what disks it has mapped. So let's take a look at that. And as you can see, the hard disk 4 is 20 gigabytes. And if I expand that a little bit, you can see that it's going to cube walls. And this is telling you that it's mapped to a PVC, so persistent volume claim. So let's take a look at that here. And if I do here kdescribe PV, now you can see that it's the exact same volume. So now if we map it back, kget nodes -o wide, if we map it back, now you can see that volume is on 2.8. So what I'm going to do is I'm going to kill this MySQL pod, and it may get scheduled on some other node. So let's go and do that. So I'm going to say kp delete MySQL -0. And let's go delete that pod. I forgot the word pod. So let's go delete that. And now if I do get pods, now you can see it's being terminated. In the meanwhile, if we go back here and take a look at this, that remember, this is the 2.8 was the old node. Now it may get scheduled on, so right there, it's reconfiguring the virtual machine. And I wonder if the pod got rescheduled on the same node. So let's go take a look here. And let me clear the screen again. So unfortunately, it got scheduled on the same node. So what I'm going to do is I'm simply going to stop this node, and that will show you the other feature of BOSH, that it will, as soon as you stop this node or if the node dies, BOSH will recreate that node. So this will achieve two things for us. A, it will show you how BOSH can resurrect a Kubernetes node if it dies. And second thing, the persistent storage part. So I'm going to go and stop the 2.8 node. So let's go to vCenter, and I'm going to stop it here. So I'm going to power it off. And once it's powered off, now you can see it's being powered off, and it takes a little while. But once it's powered off, in about 1 minute and 40 seconds or so, BOSH is going to realize that the node is not responsive. So it will initiate the resurrection of that node. It will first go and delete the existing node, and then it will start recreating that node. So let's go take a look at in the meanwhile here to see if Kubernetes knows about it yet. So these are our nodes, and these are MySQL. So MySQL is still on 23D5 because BOSH hasn't gone and deleted that node yet, and Kubernetes doesn't know about it yet. So now you can see that Bosch just powered off that node, so 10D, which was 2.8. So now if we go back here and look at our pods, now you can see that pod is being recreated, and same thing with this front-end pod, which was on that node. So we have to be a little patient here and keep watching this pod. Oh, it's up and running, and now it's being scheduled on 4B597B5. So let's see what node is that. So 4BC5, and if we look at it here, 4BC5, and that's 2.5. So if we go back and take a look at the 2.5 node, and let's see if the disk got mapped to it. So I'm going to go to 2.5 and then take a look at the configuration for it. In the meanwhile, Bosch is, notice the other machine is getting powered on. So Bosch is resurrecting and recreating that node. So in the meanwhile, if we take a look at it here and go to my hard disk 4, sure enough, that now it has mapped the disk there. And if I go back to my application is hopefully still up and running. It's still load balancing, 16.2, 16.6, and all the connectivity works. So this is what I was planning to cover today. Quickly, I just wanted to show you a quick preview of monitoring, which is an important aspect that Wavefront, which is software as a service, can give you monitoring capability per pod and for application and for the container. We have an upcoming session that Steve will talk about that's coming up in later on this month or next month. But I would highly encourage that you attend that session to get details on this very important topic of management. Well, thank you all, and you have a great day. Take care.
All right. Thank you, Virtual Sachin. So got a final poll question here before we let everyone go here. So, basically I want to find out, like, from most of the folks on this phone, what's going to be your status with Kubernetes? Are you already using it today? You thinking maybe in the next 6 months you're going to stand it up, next 12 months? You're going to use it, but you don't have any specific time. Maybe see what the results are here. Give me another 10 seconds. Don't forget to hit submit. Looks like we need a little more time for folks to respond. And let's go ahead and shut it down. Great. So what do we got here? So company is using Kubernetes today. We got about a quarter of you on the phone that you're using Kubernetes today. Within the next 6 months, about 20%. Within 12 months, a third roughly, and then sometime in the future. So pretty even split amongst all the time frames. Great to see. Thanks for taking the time to fill that out. Okay, so to kind of summarize PKS, this is all about providing a fully supported production-grade Kubernetes. We've got deep integration with NSXT. I think I saw in the chat window that, hey, do I have to use NSXT? And the answer, the response I usually ask is, what are you going to use instead from a networking perspective? NSX is actually included with the product, provides that single source of truth. So keep in mind that you don't just make networking go away. You got to solve the problem some way, and NSX is a great way to do it. The constant compatibility with GKE, that's going to be helpful for the people actually using Kubernetes, consuming Kubernetes. That's going to give them the comfort level that the features and functionality that's available matches with the major public cloud provider behind Kubernetes. Security, scanning, notary. We didn't talk much about Harbor as a container registry perspective, but it certainly provides that. And then from a security perspective, microsegmentation with NSX is huge. Runs on vSphere and GCP today. I saw that question around, what about the other major public cloud providers? We're working on it. Certainly, the technology already exists with Bosch and its CPIs to all the major public cloud providers. It's just a matter of hearing the demand to support and setting up our QA and QE to support those different environments. And then finally, storage persistent monitoring operations. Those are great tools. Now, all right, so you say, all right, I'm just starting my journey, or I'm just playing around with it. Where do I go from here? Well, certainly today we have HOLs from VMworld last year. We actually updated HOL 1832 to support PKS and Kubernetes. And of course, those HOLs are going to be reset for the upcoming VMworld. Big thing here, all those links you saw throughout the presentation, they're available on our Cloud Native YouTube channel. So feel free to check that out. Lots of different light boards. You can talk about just generic container technology or dig deeper on PKS. We do have a lot of, if you're going to VMworld, we got a lot of sessions in VMworld. The two you want to look out for are the Cloud Native track and then the DevOps track. Those are going to have the most amount of container and Kubernetes information of all the tracks. And now, if you really want to just start working with it, you're really starting your journey, I'm sure you've got something at home, like most engineers, where you've got a lab environment and whatnot. Try and deploy something with a container. Dig in. Do that, Container Basics 101 HOL at the top, and then go deploy something at home. If you want to make it a little more real, go talk about storage persistence to the people that are using containers. Typically, they haven't ventured down that because it's been a little bit scary because of the difficulty of storage persistence. But man, with vSphere, we give you that easy way to actually configure persistent storage on existing data stores. So that could be a way that you could immediately start helping the team and just organically start to learn about containers and running containers in production. So I appreciate everyone watching. Look for me at VMworld. I think I have one session. So if you want to search on my last name, Tegler, I got one session where I'm going to talk about reliability engineering, but we also have, of course, a ton of other stuff on Cloud Native, which I just talked about. And I appreciate everyone tuning in today. Take care, everyone.
Technology-driven innovation is disrupting every market and industry, and it's being created by people like you, catalysts, innovators, and disruptors. Advance your career and preview technology's next chapter. Collaborate with your peers and share your stories. Meet our ecosystem partners. Get fresh industry perspectives, training and certification, and expert-guided hands-on labs. VMworld begins with you.